Now we're going to talk about U substitution or U sub. And we kind of groaned about this a couple of weeks ago in class, but um, just like we have a chain rule for derivatives, we basically have a chain rule for integrals. Or another way to think of this is like how to undo that chain rule that you did with derivatives. If you're taking the integral, you're trying to undo a derivative, how to undo the chain rule. So before we get into integrals, let's remember how to do chain rule with derivatives. So differentiate each of these functions. So dy dx for part A should be 3 times the quantity 2x plus 1 squared times the derivative of 2x plus 1, which is 2. And we're not going to simplify each of these. We're just going to make sure we remember how chain rule works. Y prime, the derivative of sine of something is cosine of that thing, so cosine of 4x, times the derivative of 4x, which is 4. This is first a power rule. Dy dx is 3 times cotangent squared of x. And then it's a cotangent function. So nested within something to the third is a cotangent function. The derivative of cotangent is negative cosecant squared x. And then if I needed to, if there was something nested inside the cotangent function other than x, then technically it'd be times the derivative of that. Technically there's a times 1 there, but we don't usually show that. All right, so indefinite integrals. If you're integrating composite functions, what do we mean by that? First of all, you have to figure out like what your nested function looks like. And sometimes you might do a little trial and error, or you might pick a harder way compared to an easier way. So when we say a composite function, look at this first one. We know how to integrate square root of x dx. But what do we do with square root of 2x minus 1 dx? So let u equal your inner function. So write that below. U is equal to the inner function, which is 2x minus 1. Differentiate with respect to x. So find du dx. It's equal to, I shouldn't have written that right there, du dx is equal to 2. Solve for dx. Now this is kind of optional. So, but I like to do it, especially when you're starting out. What does solving for dx do? So derivative of u with respect to x, it means like multiply the dx over there. And then get dx by itself. Du divided by 2 is equal to dx. Why would we do that? Because step 4 is a really important step. Substitute means rewrite the entire integral in terms of u. So you've got the integral of the square root of u instead of 2x minus 1. And instead of dx, you're going to put in du divided by 2. And we can clean that up a bit, right? This 1/2, this divided by 2, can go out in front of the integral. So now I'm integrating a function in terms of u with respect to u, and I get 1/2 times what? Well, u to the 1/2, when you add 1, you get 3 over 2, and so you're going to get u to the 3 over 2, and instead of dividing by 3 over 2, we say times 2/3 plus c. Okay, 1/2 times 2/3, so I get u to the 3 over 2 divided by 3 plus c. Now my answer can't stay in terms of u. So sorry, I did step 5, integrate. My last step is to make it final by putting back in terms of x. So my answer is actually 2x minus 1 to the 3 over 2 power divided by 3 plus c. These are indefinite integrals, so we have to have that plus c, the constant of integration again. All right, how do you know what to make the inner function and what to make the outer function? Well, that part can be kind of tricky, right? So I tend to think like inner functions are in parentheses. They're more complicated. You'll see as we go through some of these that like you'll have to make one thing the inner function so that the other x's in the equation can kind of go away. So let me stop talking and just do some examples. So let's just try it. The worst thing that can happen is it doesn't work and we picked the wrong u, and we'll go back and pick something else. Looks like x squared plus 1 to me is the inner function. So now find du dx. That's 2x. Solve that for dx. Du divided by 2x is equal to dx, right? Multiply dx over, divide by 2x. I think this is a really important step, and I think it's silly to skip it unless you're really well practiced with u sub. All right, what can I sub in so far? I can't sub in for this x, that's still there. I can replace the parentheses with u squared, and I can replace du with du divided by x. Here, 2x, sorry. Here's the beauty of solving for dx like that. Things cancel out, right? This x cancels with this x. I cannot integrate until I have everything in terms of u. All right, so now it is, again, there's a 1/2 here. 1/2, let's just pull that out. Now it's u squared du. That's easy to integrate, right? We've got 1/2 times u to the third over 3 plus c on the end. So 1/6 times, what is u? Let's go back and sub it back in. Or maybe I don't need the 1/6. Maybe I just want it to say x squared plus 1 cubed over 6. Maybe I like the looks of that better. It doesn't matter. Plus c. So what did I mean by like, what if you chose the wrong one? What if you just said like, let's let u equal x, du dx equals 1. You wouldn't have had any way to cancel out this like x squared plus 1 piece. Here, when I let u equal x squared plus 1, when I solved for dx, I got these x's to cancel. So if you ever get yourself kind of stuck, you'll realize you might have subbed for the wrong thing. You can also start to see this ahead of time. I can see right now that the derivative of x cubed plus 1 will be 3x squared, which I have. So that's kind of nice. All right, so let's let u equal x to the third plus 1. And let's let du dx equal 3x squared. And again, you can solve for dx, which I would suggest doing, or you can kind of see this ahead of time. Like if you just multiply the dx over, like, oh, hey, I have that 3x dx. I have du. So it's just another way to show that like you're going to get the x's to cancel out. But I want to keep things consistent. So let's solve for dx by making it du divided by 3x squared equals dx. And then let's start subbing in what we know. This 3x squared is still here for the time being, times square root of u. Instead of dx, we'll write du over 3x squared. And then yes, these 3x squareds cancel. So there's no constant to pull out of this one. It's just the integral of the square root of u du. When you integrate square root of u to the 1/2 becomes u to the 3 over 2 times 2/3 plus c. And finally, sub back in. You are allowed to take the antiderivative and sub back in one step. I'm just not doing that for notes purposes. And I don't know. I think combining multiple steps gives you more room for error. All right, now what about this one? 2x plus 1 times x squared plus x. I could choose to FOIL those together, right? And then just take the integral of each individual term. That doesn't seem like that would be all that bad. So I could do it that way. Or I'm noticing that the derivative of x squared plus x, which in my mind is more complicated out of those two functions, that derivative is equal to 2x plus 1. So that's a good sign. If you can find what your derivative is going to be in the equation, that kind of shows you that stuff's going to cancel. So let's let u equal x squared plus x. So then du dx is 2x plus 1. So that du is going to be, du divided by 2x plus 1 is going to be dx. And then we integrate. And again, if you've done this before, now all we have here is u, by the way. If you've done this before, you might be sort of thinking like, gosh, why do I have to write all this stuff out? I can just see that those are going to cancel, and I'm going to get u du. That's totally fine. If you can see from here that you don't really need to solve for dx, that you have that, you have du right there. Because another way to say this is, oh, du is 2x plus 1 dx. Like, don't solve for dx. You have du, then fine, right? U du. You can skip right to this point. Just do it correctly. I don't care if you show more steps or less, as long as you don't mess up. So same thing here. I'm going to write u squared divided by 2 plus c. You might say, I'm not writing that. I'm just going to get right to 2x. Oh, no, I'm not. I'm going to do it correctly. I'm going to get right to x squared plus x squared over 2 plus c. Now, if I were to square out x squared plus x and then have each of those terms divided by 2, I would get the integral of, like, if I would have FOILed this together and then taken the integral of each term, I should get the same answer. If I won't have a constant term here, and I guess I won't have a constant term here either. Remember, the plus c gives you a little bit of leeway there, but they should match up exactly. I can see it again. If I let u equal 3x minus 1, du is going to be 3 dx. So I can see that I have it. But if you want to be very methodical about this, just keep going through the same steps. U is 3x minus 1. Du dx is 3. Du divided by 3 is dx. Sub in. You've got a 3 still there. You've got a u to the 4th. Instead of dx, you've got du divided by 3. Boom, boom. The integral of u to the 4th du is u to the 5th divided by 5 plus c. Let's get right to it. It's 3x minus 1 to the 5th divided by 5 plus c. What about this one? Let's let u equal 1 minus 2x. So then du, 1 minus 2x squared. So then du dx is negative 4x. Oh, I have that. Times dx. Okay, again, if you're not seeing that you have that, then solve for dx. Du divided by negative 4x is equal to dx. Set up what you have. You have negative 4x divided by u squared times du divided by negative 4x. Negative 4x is cancel. I've got the integral of u to the negative 2 du. I like to write it like that so I don't forget it was in the denominator. All right, so add 1, u to the negative 1 divided by 1. So negative 1 over 1 minus 2x squared plus c. I don't really like that. Negative 1 over, why don't we distribute that negative through the denominator and just call it 1 over 2x squared minus 1 plus c. You don't have to do that. I just think it looks nicer. All right, let's keep going. So we have, now, again, I'm going to do u sub, but couldn't I just distribute that through the monomial through the binomial and have a couple of terms to integrate? Yeah, you don't always have to do u sub. So at this point, it's kind of going to be like, well, what do you see and what do you need? So maybe you see parentheses and you just jump right into u sub. Why not? I'm assuming we would let 8 minus y to the 3 halves be our u. du dx would then be negative 3 over 2 y to the, let's see, 3 over 2 minus 2 over 2 is y to the 1 over 2. And then we've got, oh, we ran into a problem. Why is this a problem? When I solve for dx, I'm going to have a y to the 1/2 divided by a y. That's not going to get rid of the y's here. U sub failed. So is this an unsolvable problem? No. I go back what I was saying before. Wait, we didn't even need U sub for this one. We should have just gone ahead and distributed. 2 pi y times 8 is 16 pi y minus 2 pi y to the 5 halves, excuse me, dy. I don't need u sub. I have two separate terms that I can take the integral of. 16 pi y squared over 2 is going to be 8 pi y squared minus 2 pi y to the 7 halves times, instead of divided by 7 halves, might as well say times 2/7. So I didn't trust myself I didn't trust myself to not kind of mess up that math. Okay, plus c. 8 pi y squared minus 4 pi y to the 7 halves over 7 plus c. All right. Oh, I did. Gosh, didn't even see that. Okay, so anyway, we could have also put a 2 pi out here, factored a 2 pi out, and then integrated just without having the 2 pi in there, but we would get to the same thing. My answer would just have a 2 pi on the outside, not multiplied through. Okay, number 8. Let's see. I have an x squared up here, and my u is going to have an x cubed, so that's a pretty good sign. So let's let u equal, and remember with quotients, you cannot take the integral of the top divided by integral of the bottom, so you cannot separate this one out. U is going to be 1 plus x to the third. Du dx is going to be 3x squared. Solve for dx. Du divided by 3x squared is dx. And then sub in what we know. We have the integral of 10x squared divided by square root of u. And then dx is going to be du divided by 3x squared. It doesn't matter that the 10 doesn't cancel out. We need just the x's to cancel out. So the x squareds do cancel. And let's go ahead and pull the 10/3 constant out in front. I like to make this u to the negative 1/2 to show myself that I've got a negative exponent. So it's going to be 10/3, and then we've got u to the positive 1/2 divided by 1/2, so times 2u to the 1/2 plus c. So that's 20 times 1 plus x cubed to the 1/2, or you could make that square root, all over 3 plus c. All right, again, if I try u sub, and I do du dx, I get 2x, and then I realize, like, wait, when I put in du divided by 2x, I'm not going to have an x to cancel out here. So u sub doesn't work. It's not always going to work. What else could I do? If u sub doesn't work, how can you rewrite it? You can square out x squared plus 1, x to the 4th plus 2x squared plus 1 dx, and you can take the integral of each term. X to the 5th divided by 5 plus 2x to the 3rd divided by 3 plus x plus c. All right. Let's let u equal 5x. Du dx would just be 5. du divided by 5 would be dx. So we have the integral of 5 cosine of u du divided by 5. The 5's cancel. The integral of cosine is sine u plus c. And now I'm going to write it as sine of 5x plus c. If that 5 wouldn't have been there, then it would have been cosine of u du with a 1/5 out in front. So the answer would have been 1/5 sine of 5x plus c. So it's okay if numbers aren't canceling. You just need it to be so that you can rewrite everything in terms of u and not have x's left over. All right, let's see. We've got secant, tangent, there's an x squared in there's an x on the outside. X squared is inside of both the secant and the tangent function. So let's let u equal x squared. Du dx is going to be 2x, so that's a good sign because I'm going to get an x to cancel there. Du divided by 2x is equal to dx. So let's rewrite what we have. We have x times secant of u, tangent of u. Instead of dx, we have du divided by 2x. So the x's cancel, that's what we needed. There is a 2 in a denominator, or there's a 1/2 out in front. And we should be saying, secant tangent seems familiar. That is the derivative of secant u. So I have 1/2 times secant, wait, is that the derivative of secant u? Or secant squared? Oh yeah, that's the derivative of secant u plus c. And then that's 1/2 secant of x squared plus c. All right, what about this one? This is kind of weird. We have this nested function of 3x, but what is this sine squared cosine stuff? We're not allowed to split it. Remember, we don't have a product rule here. We don't have like integral of sine squared times integral of cosine. That's highly illegal. You can't do that. We are going to need a little bit of u sub though. So let's let u equal 3x. Du dx is 3. So du divided by 3 is dx. So there is going to be a 1/3 out here. That doesn't cancel anything, but there are no x's to mess with. So let's just put this in. Dx is now du over 3. So I'm just going to jump right to 1/3 integral of sine squared u times cosine u du. I don't have any trig value that I know, like the derivative of that is sine squared cosine. But I do have a Pythagorean identity rearranged. Sine squared is equal to 1 minus cosine squared. So why don't we try that? 1 minus cosine squared of u times cosine of u. My pen just stopped writing. That's great. Give me a second here. Our little stylus pen needs to go back into its home to get recharged every now and then. 1 minus cosine squared of u, cosine of u, du. And that helps me because I can go ahead and distribute. 1/3 times the integral of cosine u minus cosine to the third u du. I can take the integral of cosine u here. Oh, wait a minute, but I can't do it of cosine cubed, so that didn't help me either, did it? All right, well, let's go back and see what we have to work with. So I thought we were getting somewhere, and then I realized, oh, wait a minute, I'd be good here, but what about this guy? Okay, so back to the drawing board. Let's go back and look at our 1/3 integral of sine squared u cosine u du. Well, you have a sine and a cosine, and that sine squared, looks a little more complicated, right? So how about instead of saying u here, because I'm going to use a different u sub, let's get rid of the 1/3 and put those back to 3x's. All right, what if we let u equal what I consider to be the nested function sine 3x, right? I don't want it to be sine squared. I want it to be sine 3x. Okay, so let's let u equal sine of 3x. Then what's du dx? The derivative of sine is cosine 3x, and then the derivative of 3x is 3, so let's put that out here. Does that does that help me out? Yes, because when I solve for dx, this cosine of 3x is going to cancel with this cosine of 3x. Okay, so let's rewrite what we have. We have the integral of sine of 3x, instead of sine squared, it's u squared, cosine of 3x, and then what's dx? Dx is du divided by 3 cosine of 3x. So the cosine of 3x is canceled, so I don't have this in terms of x anymore. I've got 1/3 times the integral of u squared du. So you can see it takes a little trial and error, and even I forgot as I was going through this the proper u sub, but I think that's ultimately a good thing. Anyway, I get 1/3 times, it's going to be u to the third divided by 3 plus c. So we can just make this 1/9, and u to the third is sine to the third of 3x divided by 9 plus c. All right, we've got a couple more. And again, if we're running out of time or if we're getting close, our homework will be to watch the end of this video anyway. All right, so let's use kind of the same idea that we had before for this problem. So cosine squared I would consider to be more complicated, and so the nested function is what's being squared. Let's let u equal cosine of theta, and du d theta would be equal to negative sine of theta. So du is divided by negative sine theta is d theta. So we have u squared sine of theta times du divided by negative sine of theta. The sine thetas cancel. There is a negative, so don't lose track of that. It's negative integral of u squared du. That's negative u to the third divided by 3 plus c. And that is negative cosine to the third of theta divided by 3 plus c. What about this one? First of all, we should be suspicious. We see all these parentheses and stuff. 1 plus tangent squared should jump out to you as secant squared. Cosine cubed of 4x times secant squared of 4x dx. And don't dive right into any u sub, because this, we can simplify this, right? Cosine cubed times 1 over cosine squared is just cosine of 4x dx. And now this should be pretty easy. We do have a nested function. U is 4x. Du dx is 4. So du divided by 4 is dx. So it's really the integral, it's going to be 1/4 the integral of cosine u du. And I made that jump because dx is du divided by 4, so I went ahead and pulled the divided by 4 out in front. 1/4 the integral of cosine is sine. Instead of u, let's just make it 4x plus c. Call it a day. General rule here. Excuse me, I thought I was going to sneeze. General antidifferentiation of a composite function. So this is a kind of a complicated way of looking at this. It can be confusing, but you're trying to integrate. And you have f prime of g of x times g prime of x dx. So you've got a derivative that used a chain rule, right? It's going to come out to f of g of x plus c. Again, this is saying I've got f prime of u, and I've got the du piece, and when I integrate, I get f of u plus c. If u is gx, then du is g prime of x dx. So that's that substitution that I was making. And the integral of f prime of u du is equal to f of u plus c. So I just wrote that out there without reading below. Just like we have a chain rule for derivatives, we can undo a chain rule with antiderivatives.